Before we are going to see that, firstly we have to see the equation of that standing wave. What is that standing wave? Again, when two identical waves, if they possess same amplitude, same time period, same frequency, and they are going to interfere each other, they are going to travel along the same path, then they should superimpose on each other, and therefore they forms a standing wave. Just we are going to find the equation of standing wave. For that purpose, we have to consider two waves. First wave, that is y1 is equal to a sine in bracket n lambda minus x by n t minus x by lambda bracket close. This negative sign indicates that this wave is traveling along the positive x-axis direction. If we are going to see another wave which is traveling exactly to opposite of that, a sine n lambda plus x by lambda. y2 is equal to a sine in bracket nt plus x by lambda. Again, there is a plus sign which indicates that this second wave is traveling exactly opposite to that of first wave. Therefore, as these two waves, they are having equal amplitude, equal frequency, equal wavelength, same time period, and they are traveling exactly opposite to each other. First wave is traveling in positive x-axis direction. Second wave, which is traveling exactly opposite direction, that is negative x-axis direction, and therefore these two waves, they are going to interfere each other. A standing wave is formed, a stationary wave is formed. If we are going to see the resultant of these two, therefore the resultant wave can be given as y is equal to y1 plus y2, and in our theory lectures we have computed that the resultant y can be given as a sine in bracket omega t sorry 2 pi n t. This is equation number 3. Adding these two waves, and after solving them, we can find that resultant wave having the equation like this: y is equal to a sine in bracket 2 pi n t bracket close. Where we have that this value omega is equal to 2 pi n. Therefore, the equation becomes, what is that equation? Let us see. Y is equal to, instead of that 2 pi n, we are going to put omega a sine omega t. This is the another type in which this equation 3 can be written. Again, here we are going to say that where capital A, it is equal to, it is the amplitude of a resultant wave, the resultant wave which is having this amplitude A. Therefore, again, if we are going to put the value of A, the value of A is like this. Capital A can be given as twice of A cos 2 pi x by lambda. That value of amplitude, resultant amplitude, is equal to capital A is equal to twice A cos 2 pi x by lambda. This is the amplitude of resultant wave. Now, if we are going to draw a stationary wave or a standing wave, it is going to look like somewhat this type. Just we are going to draw that wave. The medium must be containing the boundary, and therefore there must be a reflection of wave from that point. Like that. Now, these points A, and A, these are the antinodes, whereas the points which are at minimum displacement, they are called as nodes. There is a rigid support where we are going to see that the reflection of two identical waves. These are the transverse waves which are superimposed, two transverse waves, and these two waves we are going to draw in different two colors, and these two waves, they are traveling exactly in opposite direction. Therefore, see what happens. There is a formation of antinode and nodes. Again, there is the node 1, 2, 3, 4, 5, and antinodes 1, 2, 3, 4, and the 5. It means that we are going to see that in case of a vibrating string, just for remember, in case of vibrating string, it can be seen that the number of nodes, they are exactly equal to number of antinodes. It can be seen that. And if we are going to describe the distance in between that of antinode and node, or two successive nodes, in case of wavelength, therefore again we are going to draw that a wave must be drawn. There is a wave, just we are going to increase again. The number of loops must be increased for that purpose. Again, going to draw that wave like that, like that. See now, there is a distance up to this point. To this point, we are going to say it is a lambda, that is a wavelength. It is a wavelength of a wave. It is a wavelength of a wave which contains a total loop. Now, the distance between these successive or consecutive antinodes, these are the antinodes. This is A, and A. Then Yan, again Yan, and Yan. See what happens? Distance between these two is the antinode. In between them, it is a lambda by 2. Distance between that two successive nodes, again it can be seen that it is the half the wavelength. Therefore, it is also is equal to lambda by 2. It means that the distance between two successive antinodes or nodes is equal to lambda by 2, whereas the distance between adjacent node and antinode, it is going to be lambda by 4. This is a standing wave. It can be seen that it is going to say that it is localized, or it is a standing wave, because the wave does not go in forward direction or reverse direction. It is just standing there. Therefore, it is called as a standing wave, or it is also called as localized. It remains localized.